and I do
All
have
right.
a brief introduction, Bob.
Oh, you do?
Yes. This program will be recorded and it will be made available on the Detroit Public Library YouTube channel and through Wayne State University's website. I'm Jennifer Dye, a librarian at Detroit Public Library. DPL has had astronomy programs for the last several years, and when things fell apart in spring 2020, we put the programs on hold for a while. We finally launched astronomy programs on Zoom early last year. Over the last several months, we've worked with Megan McCullen, director of the Wayne State University Planetarium, on programs presented by Wayne State faculty and alumni. And we're going to continue that, and Megan continues to help me, for which I am very grateful. She will be gathering your questions from the chat. Please put your questions in the chat. Next month's program will be a look at star life cycles, presented by Ken Burton, who is also in the Warren Astronomical Society, as is Bob and me. I think Megan is too.
Not paid.
Okay, I'm a bit behind on payment too. I'd like to ask Megan to speak briefly before I introduce tonight's speaker.
Thanks, Jennifer, and thanks, Bob, for being here. Hi, everyone. We're glad to be a part of this. I always enjoy these talks. We were going to have our first in-person event last month, and we announced it here for the Wayne State Planetarium, and then we got terrible weather, so it got postponed. So we are having our first in-person event in May. We're going to be out on Belle Isle at the Belle Isle Nature Center, working with them to look at the moon on Saturday, May 7th from 8:30 till 10:30 p.m. And we'd love to have folks come out, bring their own telescopes and share with others, or come use our telescope.
Oh, tempt me not.
Yeah, and we've never done viewing from Belle Isle, so we're right in the city. We're not sure how well that will go, but the moon should look great. That's why we're starting with the moon. And hopefully we'll be doing more programming out there after that once we get a handle on running events there. So I will post a link in the chat so that you can find out more information about it.
I'm gonna have to make sure the WAS knows about that.
Yes, I need to get that information out to everyone. Since it's our first time, we've been focused on the local community mostly, just because we have no idea how it's all going to run. We don't have the kind of setup they do for astronomy at the beach to really block out everyone's lights and stuff. So we'll see how we do, but that'll be great. And I'm going to take your questions in the chat. Feel free to send them to me directly if you don't want to post them in the public chat, or if you have a lot of questions, that might be the best way to get them to me. And we'll answer them at the end of the show. So thanks.
Thank you, Megan. Bob Trembley is a volunteer NASA JPL Solar System Ambassador, the first vice president of the Warren Astronomical Society, and a factotum for the Warren Observatory Fund. For the Vatican Observatory Foundation, not Warren. Bob, thank you for joining us, and he is going to show us some cool software.
I am. All right. So like she said, that's me, set up at a science fiction convention. I do a lot of that. I am a volunteer NASA JPL Solar System Ambassador. This is a program that NASA has where they look for people that do a lot of outreach and stuff like that, and they recruit you, and you get to sit in on teleconferences with mission specialists, engineers, scientists, and get the latest scoop on what's going on, and then give that to the public. And so that's awesome. I get freebies that I can hand out. Just love doing that stuff. I am the first vice president of the Warren Astronomical Society. They just can't get rid of me. Not that I've been trying. The factotum is a great word. Essentially, it means just somebody who does a lot of different things, and that's what I do. I am a podcast host for them. I write astronomy and space science posts, and do their newsletter, and just a ton of stuff for them. And you should go there and read their stuff because they got a lot of cool stuff. My boss is essentially Brother Guy Consolmagno, and on these podcasts, the last one here is these two guys were responsible for getting me into the Solar System Ambassador program. So very cool. I'm going to be demonstrating tonight using a package called Space Engine. It is available on Steam for $25. It is amazing. You can go anywhere in the universe. A recent update, like April 5th, they included all of the most recent exoplanets that have been discovered. And here you can see they've included volumetric rings, so you can actually go see the ring particles. I'll stop talking and show it to you. So let's stop sharing that and share the app. All right, where's the share button? There we go. Space engine. All right, are we looking at the solar system here? Okay, good.
Good.
Starting out, here's the outer solar system. Let's just take you right into the sun. Past all the planets. Okay, there is our sun. Now, this is not real time. That's just a representation. But let's zoom way in. Now, the sun. I said I have a presentation about the sun. I love talking about it. What you're seeing there on the surface, a little bit. Those are called granules. Those there's millions of them on the surface of the sun. The sun really doesn't have a surface. It's gas, but essentially this is the photosphere. These things are about the size of Texas, and they last about 8 minutes. And the best way to think about these things is like a lava lamp. It is plasma. It heats up, goes to the top, cools off, and comes down. And these are called granules. So here's you're looking at the surface of the sun here. And it's kind of lumpy. So let's go out and go to Mercury. Let's turn those orbit lines off. Blank. Now, the first thing you notice about Mercury is it looks a whole lot like the moon. Although it is the closest planet to the sun, it is not the hottest place in the solar system. As a matter of fact, on the North Pole here, there have been they have recorded the coldest temperatures in the solar system, and the Arecibo radio telescope, before it collapsed, discovered ice on these spots. So some of these craters never see the sun, and so there's ice that could have been there for a very long time. The cool thing about Space Engine is that for all the solar system objects, they've got high resolution NASA imagery, so it is just beautiful. So that is Mercury. These would be images from the Magellan probe. So let's go to Venus. Venus is very bright in the eastern sky in the morning right now, and it's full of clouds. And you can't see any surface features unless you turn the clouds off, and then you can see radar images of the surface of Venus. I have an article here from about a year ago talking about they have discovered that there might be active volcanoes on Venus, and there are going to be 2 missions sent to Venus in the very near future. So I am looking forward to those. Venus, it's been called Earth's twin. It's only a twin in size. Its atmosphere at the surface is like 90 bars, 90 times the pressure here, and it can melt lead. So it is a very unhealthy environment. It eats landers. Oops, didn't want that. Let's go to Earth. Home sweet home. Yeah, the cool thing about Space Engine and the Earth is the night lights. Let's get rid of the labels. These night lights are accurate, and let's find the United States. Where am I? There we are. How did I get all bent around like that? All right, so let's time accelerate here. Get the United States in the dark. All right, these night lights, you can see these things at NASA's Black Globe website, but this is what the Earth looks like on the night side. And cities have a look to them. There's Detroit, Chicago, Minneapolis, but over here, does anybody know what that is? That's North Dakota. Those are fracking fields. Yeah, so the entire area there, bigger, much bigger than Minneapolis, St. Paul. And if you go down to the Gulf Coast, all those little dots in the coast, those are oil rigs. So you can see these fracking fields in other places around here too. So that's the Earth at night. So there is our moon. So let's actually, I can go to a location here. They have Apollo sites landed. So locations. Here, the Apollo sites. There we go. The Eagle is landed. This is Apollo 11. Oops. So take a look at how flat that area is around that lander. They weren't taking any chances at all. So it incredibly flat. Now let's go to Apollo 17 and see the difference. Hopefully it's not going to go through the moon, but it did. There we go. Yeah, all right, fine. So have a look at the terrain around the Apollo 17 lander. They got a little more confident when they hear here. This is just yikes. I'm glad they didn't do that on the first one. Okay, Mars. We've got several. Mars is completely inhabited by robots. I love that phrase, and it certainly is. Mars has some very large volcanoes right there. And let me zoom out and find, there it is, Valles Marineris. This thing is like the Grand Canyon, only it is huge. I mean, it covers much of the planet. And the cool thing about Space Engine is I can just go right down there. And I'm in Valles Marineris, and I can fly like a drone down Valles Marineris. I just love this. Phobos is, yes.
Since we just got a specific question related to that, so I thought I'd jump in with you.
Go to, what do you got?
Is there evidence of a tectonic origin for the Valles Marineris troughs?
Oh, heavens. I do not know.
Fair enough.
I'm sorry. But you know, I have the tome of all knowledge, so I can probably find out. Okay, this is Phobos. This is the large moon of Mars. And you'll note one thing, as it orbits Mars here, it's always keeping one face towards Mars. That's just like our moon. It is tidally locked, as is Deimos. And if you take a look at a list of tidally locked worlds or tidally locked moons, there are a lot of them. Many of the moons in our solar system are tidally locked with their parent. Phobos is very close to Mars here. And I saw an article just the other day about in a few million years, it's probably going to get ripped apart and Mars is going to have a ring system. So that would be interesting. Ceres is it used to be classified as a planet. It was discovered in 1801. It was classified as a planet. This sits comfortably between Mars and Jupiter, where we have where we call the asteroid belt now. But more and more objects Ceres was a lot, they discovered that Ceres was a lot less like Mars and Jupiter and the things on the other side of it, and a lot more like the things they kept discovering where all the asteroids are now. And so it got reclassified about 40 years later as an asteroid. And then in 2006, when they discovered it was completely round and an icy body, it got reclassified as a dwarf planet along with Pluto, which upset a lot of people. But so Ceres is an icy body. It is a lot like a trans-Neptunian object or the icy moons of Jupiter and Saturn. Why is it in the asteroid belt? It doesn't belong there. It is most of the mass of the stuff in the asteroid belt. This is Occultar crater. I believe that's how it's pronounced. This is a very prominent crater on there that it had cryovolcanism going on, and this is like, I believe it's sulfates that came out of there. There's several of these white spots on Ceres. The Dawn probe went to Vesta and Ceres and orbited both of them. It was the first spacecraft to orbit 2 solar system bodies. It used an ion engine to get there, and ion engines are very low thrust. From what I've heard is if you take a sheet of paper and put it on your hand, that force is how much the ion engine push. But if you do that for months at a time, you can go very fast, and that is how it got to these two. The Dawn probe is now in orbit around this at a 50-kilometer orbit in a parking orbit. So let's go out to let's go to Comet 67P. There it is. They actually have a really good model of this one here. This is Comet 67P Churyumov-Gerasimenko. It is a bilobed comet. The ESA, oh, for crying out loud, I can't remember the name of the probe. Senior moment. Well, this comet was actually landed on, and the probe was rendezvoused with this and stayed with it during its periapsis around the sun, so it got to see it jetting and stuff like that, and it's just amazing. The images from this and the animations. This is a very oddly shaped object, and you see a lot of objects in the solar system that have these 2 lobes in them like that. All right, Jupiter, king of the planets. This guy is a monster. It is currently being orbited by the Juno mission, and we are going to be sending the Europa Clipper mission to it, which, yay, it's going to be gravity assisting by Ganymede several times, and then orbiting where essentially the low point of its orbit is going to be where Europa is, and then it's going to whip around, and it's going to encounter Europa like 44 times. And so that is going to be amazing. Jupiter, let's turn on orbits. So there's the purple line is the Juno mission. The Juno mission gets really close, like in 3,500 to 5,000 kilometers from the surface of Jupiter's cloud, or from Jupiter's cloud tops. Jupiter also, like the sun, doesn't have a surface. It's all gas all the way down until it just keeps getting thicker and thicker. So you might have seen Jupiter's moons in a telescope. The 4 moons that you can see here, the big ones, the Galilean moons. But Jupiter has 79 moons. What does that look like? Well, let's turn them on, because I can do that. Dwarf moons, doink. So there's a couple of them here inside of Io's orbit. They're mostly asteroids, but most of them are way out there. Those are Jupiter's moons. There is a ton of them. And some of these guys, click on this guy, well, orbital period 1 year, orbital period almost 2 years. So some of these guys, they're 2 years. Some of these guys take like 2 years to orbit Jupiter and their moons. And again, most of these guys are comet-like or, asteroid-like. But let's turn those guys off and go back to the Galilean moons. Okay, the four big ones are, well, let's start with Io here. Io is the closest to Jupiter. Jupiter's gravitational force is stretching Io as it orbits, and Io is the most volcanic body in the solar system. There are hundreds of active volcanoes, and as you'll note, there are no craters on that surface at all. It is being completely resurfaced by those volcanoes. So that is really cool. Most volcanic body in the solar system. Europa, attempt no landings here. Europa is an icy body. It's got a lot of cracks on the surface. And recently I saw that they think that there is plate or ice tectonics going on here. Now, I told you about the Europa Clipper mission, which we're going to be sending to Europa. Well, why? Well, you may recall the mission to Saturn called the Cassini mission, and it found around Enceladus these jets coming out, and they found jets on Europa. What causes those? Well, if you ever heard of hydrothermal vents, or these deep vents and in the mid-ocean rifts and stuff like that, that could be happening under the ice of here. Jupiter, again, you're most of the Jupiter moons, the big ones, Jupiter's gravity is stretching them. And even if it does it just a little bit, that creates a lot of energy, and it could create those hydrothermal vents. Hydrothermal vents on the Earth have diverse ecosystems that are not like anything on the surface. So that could be happening there, and it could be happening on Saturn's moon Enceladus too. So that is why we are sending the Europa Clipper here. Oh, speaking of which, well, yeah, my wife and I run an after-school astronomy club, and last week I was lamenting about the fact that, you know, Uranus and Neptune have only had one flyby mission, and every time the NASA decadal survey comes out, I'm like, sending something out to the ice giants, and it never happens. Well, the decadal survey came out this last week, and we're getting a Uranus orbiter and a probe that's going to go into the clouds, a Enceladus, that's that icy moon of Saturn, orbiter and lander, Mars sample return. I am just thrilled. The next 10 years of space exploration are going to be amazing. So that is Europa. We are going there very soon. Ganymede, where's Ganymede? Where's close to which one? I never know the order of it. There's Ganymede. Ganymede, I believe, is bigger than the planet Mercury. So it's a moon of Saturn, and it's got a very interesting surface. It does have some craters, but this thing, I believe it's been called tortured. Look at that impact crater. So again, icy moon. It too could have a subsurface ocean, and the Europa Clipper mission is going to be using this guy to lower its orbit the first couple times it's in the Jupiter system. And Callisto, furthest one out of the big guys. Definitely a lot of craters on here. Another icy moon. Really pretty. So yeah, the moons of the outer planets are all pretty much big ice balls. So that's the Jupiter system. And let's go to Saturn, my favorite system. Yoink. All right, Saturn has, like Jupiter, bunch of moons. That would be the Cassini mission, which is ended in 2016. It burned up in the atmosphere of Saturn, and I actually cried. That's the Cassini mission to Saturn has to be my favorite mission. So I was mentioned, yes.
I think you're going to go there, but we have a specific request that you visit Titan as part of
Titan. Oh, I can do that. I can show you cool stuff with Titan. All right, where is Titan? area, Titan, there it is. Titan, largest moon of Saturn. Got a very hazy atmosphere. Let's go here, see, very hazy atmosphere. And one of the things that the Cassini mission did when it was flying by Titan, and it did so several times because largest moon, gravity assist, changing the orbit and stuff. Let's see if I can find this. Get close here. I can't do it. Well, let's turn the clouds off then. Yoink. And there is the surface of Titan with the clouds off. One of the things they found on Titan, let's see if I can find it. There we go. They've found hydrocarbon liquid. They found the sun glinting off that and through the cloud layer. So Titan has an incredibly thick cloud layer. It's I believe it's like 500 kilometers thick. It's ridiculous. When we sent the Cassini mission into the Saturn system, the Huygens lander went down on a parachute, and it was designed to land in liquid or on land. They didn't know what it would be hitting. It took a long time for it to go down through the atmosphere. Titan is a big ball of hydrocarbons. If you've been following the Mars Perseverance rover mission, it has that Ingenuity helicopter. They're planning on sending, I believe it's called the Dragon. It is a monster quadricopter, and they're sending it to Titan, and it's going to have an RTG for a power source and 4 gigantic blades. And I saw something online about it. They've got the whole thing designed and ready to go. They just don't have a launch vehicle for it. So hopefully this thing they're sending to Enceladus can actually take it with them. So Titan, again, Titan is a monster. And there, let's turn off the orbit so you can get an idea. It orbits in the plane of Saturn, so a plane of Saturn's rings here. So all of the astronomical art you've seen with the rings at an angle, no, you can barely even see the rings from most of the moons, actually. So let's go to Enceladus. Enceladus. Did I get it? Now this thing doesn't animate the jets on it. Again, Enceladus is tightly locked with Saturn. Look how big Saturn is there. On the South Pole, they saw these things, and they're called tiger stripes. And the Cassini probe saw these jets coming out, and what it is they saw it, and they changed the probe's orbit, and they flew near it, and they changed the probe's orbit, and they flew through it and analyzed it. And that's where they're going to be landing when they go back. So, but this has jets coming out, and so does Europa. So they're finding those things and a lot in icy worlds. Now, does anybody? I don't have chat up here. Does anybody know how Saturn's rings got created? Any ideas?
Someone asked a question about that, in fact. So.
Well, okay. Most of Saturn's moons are icy and a little bit of rocky, and Saturn's rings are the same thing. Well, what happened is one of these icy moons got a little too close to Saturn, and again, Saturn's gravity ripped it apart, and all those particles of dust and ice spread out in an orbit around Saturn, and that's how the rings got created. Now you'll see a lot of these things. Atlas, Prometheus, these guys are really, really close to the rings, but there's one of my favorites. It's this little guy called Pan. I love Pan. It is a shepherd moon. It is inside the rings, and it is shaped like a flying saucer. Cassini actually imaged this guy. This is not quite, this is artistic rendering of it, but it looked very much like this. And Atlas is very much the same. It's got this weird ridge. Imagine what the gravitational force would be if you're like standing up there. Nope, that is not what I wanted. Dwarf moon of Saturn. I went to another star. Let's go back. Another flattened flying saucer moon. Look at that. But these guys are inside Saturn's ring plane. Now, speaking of Saturn's ring plane, you don't want to do this in a spaceship. Let's get right down there. There they are. So Saturn's rings are a bunch of particles. They are anything from dust size to boulders and stuff like that, all smacking into each other. And Saturn's rings are very, very thin. They're, I think, what, 200,000 miles across? They're less than a kilometer. I've heard actually a few tens of meters, but I'm not really sure. But it's less than a kilometer. Saturn, its ring plane, as it orbits, it can face the Earth or it can be edge on with the Earth, and when it's edge on, we can't even see the rings. So we can see it like that, or we can see it like that. Let's get behind Saturn.
Bob, do the particles that are in the ring also orbit around Saturn, or are they static in their
Yes,
location?
they do. No, they orbit around Saturn. They're all little moons. So this is behind Saturn, and when the Cassini probe went behind Saturn, you see that faint ring. It actually discovered a new ring. That faint ring right there, that's really cool. Man, our solar system is beautiful. Uranus. There's actually a video by CGP Grey on YouTube where he suggests, instead of Uranus or Uranus, which both have ha connotations, calling it Uranos. I actually like that. So this is Uranus. Stick with Uranus for now. Uranus, something hit it a long time ago, and it orbits on its side. It's like 90 to almost 90 degrees. So here's its orbital plane, right? That red line right there, and the ring plane, that would be its equator. So it is very tilted, and all of the moons orbit in that same plane right there, like that. So as it orbits the sun, that plane stays like that. So as it goes around the sun for a while, like here, pretty much, the equator is directly pointing toward the sun. As it's over here, the North Pole will be pointing toward the sun. On the other side, again, the equator, and over here, the South Pole will be pointing toward the sun. So that's got to be very weird weather-wise. Uranus has a ring system. Oops. Uranus has a, slow down. Uranus does have a ring system. It's very, very thin. Wow, I gotta slow that down. I am not sure if we're going to be finding more moons around Uranus and Neptune, or Uranus when we go there. I'm pretty sure we will, because I'm pretty sure like Jupiter and Saturn, we're going to have a ton of different moons around it. So this is an ice, the Uranus and Neptune are called ice giants. When I was a kid, they were all gas giants, Jupiter, Saturn, Uranus, and Neptune, but they are they're less hydrogen and more methane. And if you want to start talking about weirdness and ice, okay, as you go down into the planet, the Earth, as you go down to the core, it gets hotter. Well, same with these guys. And if you remember your chemistry, as you compress a gas, the temperature goes up. Well, Uranus and Neptune have methane ice that's 15,000 degrees. That's just crazy. So that is Uranus. Let's go to Neptune. This guy was only flown by once by the Voyager probes, and they found rings. There's a ring around Neptune as well. Let's see if can I get this on. Nope. But there's a very thin ring. There we go. Very thin ring around Neptune. Several different moons. One of the most interesting moons, though, is Triton. Triton is in a very weird orbit. When they took pictures of it, they saw smoke coming up and going off like that in the atmosphere. And like Pluto, it has a very thin atmosphere. It would be very interesting to go back here. But take a look at Triton's orbit compared to Proteus, the other big moon orbiting Neptune. It's likely that Triton is a captured Kuiper Belt object. And again, whoops, where on hell? Okay, back to Triton, please. I keep wanting to go to the star, and I don't know why. So this guy, if you take a look at it, it looks a lot like Pluto. And we only got a couple pictures of it as we went by. So we're not going to this in this decadal survey. I'd really wish we would go back, because I have a feeling Neptune's going to have a lot to tell us. So Pluto, planet or not, I'm not going to argue that, but it is interesting. It's an oddball, actually. Okay, so there's Pluto. Pluto has an atmosphere, and you might remember that picture that showed Pluto's atmosphere being lit up from behind when the New Horizons went by it. But Pluto has a monster moon, Charon, right there. And this, the red line, is showing you the barycenter. That moon is so big, both of these orbit around a common center of gravity. And let's get that in the center of the screen. So when these guys orbit each other, Pluto does this wobble. Now, the interesting thing, now I talked about a lot of the moons in the solar system being tidally locked with each other. Charon is tidally locked with Pluto. Pluto is tidally locked with Charon. So they both face each other as they orbit around each other. And what that means is if you land on either of those planets at a certain point, if you land on Charon at a certain point, Pluto will always be in the same spot. And same with that. And I can actually show you that. And because Pluto's orbital plane, like Uranus, is so bizarre here, the shadows get really cool. So I've actually got this saved location here. Pluto, there we go. All right, I am on Pluto's moon Charon here. Let's turn orbits off. So I'm on Pluto, and labels, please. Thank you. All right, so let's accelerate time now. that is how it looks as Charon orbits Pluto. It hangs in this one spot, and because the orbital plane is tilted so much, the shadow does this really bizarre thing. So I thought that was really cool. Oh, and there's something I forgot to show you guys about Mercury. Mercury's orbit is such, and Mercury's rotation and Mercury's orbit are such that if you land on a certain spot on Mercury, let's go find it. There we go. So here's the sun from the surface of Mercury. Real time, let's accelerate. Okay, flip it back. So this is what it does. It sets, decides to come back up, and then back down. I'll flip it around. On the other side of the planet, it'll do the same thing. And if it's overhead, it'll do that weird dipsy doodle like that. But this is called the double sunrise on Mercury. And again, you got to be on a certain spot on Mercury to see it. So that's pretty cool. So let's go back out to Pluto. Turn orbits on. And go way out. These are the dwarf planets. And there's a solar system with the dwarf planets and stuff like that. Now, you know, we have a lot of asteroids, right? What does that look like if I turn all those asteroids on? Lock that down. Orbits, yeah, doink. It looks crazy, and it starts to bring my PC to its knees, even though I got a beefy graphics PC. What you're seeing here in the inner system, these are the asteroids between Mars and Jupiter. But out here, you've got a bunch of stuff too. And these are trans-Neptunian objects out past the orbit of Neptune. Let's turn the orbits off and just turn the markers on. So there's all the asteroids in the asteroid belt. And here, these are all the Kuiper Belt objects. There's a lot of them out there. These are all in the outer solar system, and we're finding more and more of these all the time. As a matter of fact, the Vatican Observatory Foundation's Vatican Advanced Technology Telescope discovered a trans-Neptunian object that got labeled like a couple months ago. So that is pretty cool. So let's turn these off, and I want to show you how many comets we have, because that's crazy. There's just the comets. Can't eat that. There's okay. There's a lot of comets, but what's really impressive is when you turn the comet orbits on. These are the comet's orbits, and some of them go way out. You can actually see these comet orbits from other star systems. But so there, yeah, comets. We got a lot of them, and some of them have very far orbits. So let's see, what have I got here? Comet best is here. Let's go. Okay, now I've gone. This is the solar system, but one thing a space engine allows you to do is travel the galaxy and the universe. Let's turn the orbits off. There we go. Let's go a little bit out from the sun. Is that Alpha Centauri? Yeah, that's Alpha Centauri. So Alpha Centauri is a double star. You can turn orbits on and see how they orbit. Time accelerate. That is how Alpha Centauri orbits. I mentioned that Proxima Centauri it had all of the exoplanets that we've discovered until about April 5th were added into here. Proxima, yeah, there we go. This is Proxima Centauri. It's a red dwarf. It is the closest star to the sun. And it's got a bunch of exoplanets these are real. We have discovered these guys. And they actually haven't put the third one in yet. There's a new one here. They didn't put it in yet. But any of the data on these guys, the stuff here on the upper left here, that's all accurate. The visual representation, who knows what these things look like. This is just based on it's all procedurally generated and based on what something like that would look like from this location. But Proxima Centauri has several exoplanets, so we've got some rocky planets pretty close to us. Oh wait, though, it is there. Look, that's the other planet. It's way out. It says it is a frigid Neptune. So we have discovered over 5,000 planets orbiting other stars, and well over 1 million asteroids and stuff. Now, eventually the discovery rate for asteroids is going to start curving off eventually, but exoplanets, there's no end in sight for the number of exoplanets we're going to be able to discover. I think I saw that an estimate was like 40 billion exoplanets in the Milky Way alone. So Pluto and Charon, Arrokoth. Now the New Horizons mission flew by a Kuiper Belt object. After it flew by Pluto, you can go there now. It flew. They found another object, and they flew by that, and that is what. Okay, when we saw it, it looked like that. They took some pictures as they went by. They say it's flat like that. Show me another object in the solar system that's flat like that. I think they're spheres, but that's just me. But so Arrokoth, it is a bilobed object, much like Churyumov-Gerasimenko, that comet. Again, what do you think the gravity would be like if you're standing here? But you'd probably be able to jump off the darn thing and just leave it. But with this weird lobe over here, heaven knows the gravity in this would be crazy. So let's take you to some interesting stars. You might be familiar with, well, hold on, I can turn constellations on and show them to you. There's constellations. All right, let's go to, okay. All right, this is Ursa Major, this is the Big Dipper. And this star in the handle of the Big Dipper here, if you look at it with your bare eyes, you might be able to see two stars. Well, there's more than two stars there, as a matter of fact. It's really interesting. Let's just go there and watch what the constellations do when we start leaving Earth. Because you're seeing these things, you know, against the sky. A lot of these things can be very far away from each other. So Mizar is a double star, but it's more than a double star. And like Alpha Centauri, they orbit the common center of gravity like that. But each one of these is also a double star. This is a quad star system. So you've got two stars and two stars both orbiting their common center of gravity. So that is kind of neat. Polaris.
Which star did you say that was again? I'm sorry.
That's Mizar and Alcor. It is the middle star in the handle of the Big Dipper. And from what if you've got really good eyesight on a clear night, when you look up at that, you can resolve two stars. I used to be able to. I can't anymore. Even with glasses, I can't anymore. And I've heard stories that the Roman centurions use that as an eyesight test. If you could resolve those two stars, whatever. So Polaris, this is the North Star. Hey, look at that. It's a binary. And now these guys, these orbit a little different than the other two you saw. The other two have come in and orbit around a barycenter like that. This guy's barycenter is kind of weird. Now you'll note far point and close point, how they orbit like that. Let's turn orbits, turn constellations off, and turn. That is what they're doing. The dance of the stars. Oh, look at that. There's more stars there. I think Polaris, is it a quad? I can't remember if it's a quad. Let's find out. There's 2 there. Nope, just one big one. So this is a big one and 2 smaller ones orbiting right there. Their common center of gravity. So let's take you through let's take you through the galaxy. The galaxy is a big place, and there's a lot of stars. And one of the things I like about Space Engine is this looks a lot like the old Windows screensaver, the stars screensaver. But the cool thing about this is that it all pretty accurate. There's the core of our galaxy. Let's start heading off that direction. One thing yes.
All right. I was just going to let you know that one of our younger visitors tonight was asking about black holes, and I didn't think we'd get to them. But since you're going around the galaxy,
well, as a matter of fact, I can do that. So this is our galaxy. These are dust and gas as we're going through the galaxy, and this is the Milky Way that you can see in the night sky. Well, you might have seen pictures of galaxies. What does it look like when you're outside of the galaxy? Well, there's our Milky Way. It is a spiral galaxy. It is a barred spiral. It's got a bar in the center of it. It's pretty typical. Our sun is located 27,000 light years from the core, or right there. That's where our sun is. There's the core of the galaxy. Now, a lot of you might have seen, we see galaxies at all different angles. So our galaxy, if you see it edge on, we see galaxies like that. I'd love to be able to do that. So our galaxy has satellites. This is the Large and Small Magellanic Cloud. They are small satellite galaxies that are orbiting our Milky Way, and the Milky Way is probably going to be eating them eventually. There's a lot of these guys out here. You'll notice these are globular clusters. These are balls of stars, tens of thousands or hundreds of thousands of stars. A lot of them are way above the plane of the galaxy. Some of them orbit around the galaxy. Some of them plow through the disk of the galaxy, and twice as they go around. So there's a lot of them. But you wanted to see black holes. Let's go to black holes. Cygnus X1, I believe, is the first black hole we discovered. Cygnus X1, go to. Well, where are you? There we go. All right. That is a black hole, and it is very, very bright. It is actually orbiting a much larger companion star. It is probably actually, whoa, Space Engine, what are you doing? It is probably actually siphoning off material from that large star. But let's go back to the black hole. Now, what you're seeing here is the jet and the accretion disk. Let me decrease the brightness a bit so you can actually see the black hole. Still can't see the black hole. Dim, dim, dim. There it is. So this around the black hole is called an accretion disk. Let's set to real time. So that's going really, really fast. Let's slow it down. There we go. Something more manageable. So this is called an accretion disk. A lot of black holes have these. Any black hole that is near something that's pulling material, it'll have this disk around it. Probably really thin, like Saturn's rings, because gravity does that. But the gravitational force of the black hole will actually make it look like it's bending around. And if you saw the movie Interstellar, yeah, this is very similar to that effect. So these jets coming out of the black hole, what's going on is this accretion disk here. Let's turn the brightness back up because really bright. You've got all this stuff going around the black hole and smashing into each other, getting really, really hot. And there's what you've got is some ridiculously strong magnetic fields around the black hole, and this plasma is being shot out these jets. And you don't want to be there. Very, very not healthy. So that is a black hole, a companion. What happened here is this star, this black hole used to be a star, probably like this one, a very large star that at the end of its life cycle became a black hole, and now it's a companion orbiting a much larger star. But let's go to Cygnus Sagittarius A star. That is the black hole in the center of our galaxy. SGR A star. Here we go. This is in the constellation Sagittarius. If you're familiar with that, it looks like a teapot. Well, right, pouring out of the teapot is the center of the galaxy. So this is the center of the galaxy, and these are all of the stars orbiting the center of the galaxy. ESA actually used this in the video. So these are all of the stars. Come on, speed up. There we go. These are all the stars orbiting the central black hole in the core of our galaxy. And we've actually have video of these taken over several decades, and you can see stars whipping around like that. And turn the labels off, get out of there. But so you got these are stars that are whipping around, and you cannot see what they're whipping around. That would be the supermassive black hole in the core of our galaxy. Let's zoom in. I always miss this thing. Come on. So yep, there we go. I always miss it. It's huge. This thing is gymongous. Hello, stop, Elon Musk. There we go. So like Cygnus X1, it probably has an accretion disk. It has a big jet. Now, what the interesting thing with the star, this Sagittarius A star, the black hole in the core of our galaxy, there's the plane of our galaxy. Notice how it's flat on. So these jets are blasting out into the stars there and there. And again, you don't want to be there. That would be very unhealthy. But this guy, again, is a monster. Can't see it because it's so bright. Dim it down, dim it down, dim it down, dim it down. Yes, there's the black hole and the accretion disk.
Bob, can I ask a
Certainly.
question for you? We've got lots, but there's two that are related to what you were just doing.
Yes.
Somebody was asking about why the accretion disk is a flat disk and not a sphere. And relatedly, someone had asked why the Oort cloud is a sphere and not part of the plane of the solar system. So I don't know if you want to.
Oh, wow. Okay. Accretion disk. Think Saturn's rings. All right. The gravity is holding the particles or the accretion disk in, gosh darn it. There we go. Come on, stay there. So the gravity of the black hole or the gravity of Saturn is what holds the rings or the accretion disk like that. All this stuff is orbiting really, really close, so it'd be going really, really fast. Now the Oort cloud of our solar system, then, if you're not familiar with what the Oort cloud is, you've got the Kuiper Belt, which is a flat belt like our asteroid belt, only outside of Neptune. It's pretty much flat belt. Now the Oort cloud it can go out to almost 1.5 light years. It's icy bodies, lots of comets come from there and stuff, but it's spherical. Well, why is it spherical? Why isn't it being held in a flat disk? Well, I don't really know the answer to that. All thing I know is that when you get out that far, the force of gravity of the sun isn't holding them into a flat disk, and the gravitational effect of all of the planets on them is much less. And so the way the solar system formed, they're thinking that a lot of these things could have gotten whipped out due to gravitational interactions and stuff. And there's some speculation about a Planet 9, about something that we haven't discovered way out there yet, a large body that's affecting the orbits of stuff. I don't know. I've heard some conjecture about it being a black hole, a primordial black hole, and I'm like, we haven't found any of those yet. That's conjecture.
Cool. We also have a request to visit, I think it is the biggest black hole, TON 618.
Oh, where is that? What galaxy is that in?
The universe.
The universe. Well, I got the universe here.
Let me see what I can find.
Why is my galaxy so dim? What the heck?
It's in the constellation Canis Venatici. I don't know that one. Better constellations than the hunting dogs.
Why is my suddenly things have dimmed down and I don't know why. All right, I'm restarting Space Engine. I don't know what's going on here. Give me a second.
Can I ask you questions while you do it? Or
Yeah,
will that
please.
distract
Go ahead. Go ahead. That's
Okay.
fine.
What if the sun collapsed into a black hole? That was another one.
The sun can't do that. It's not big enough. In order for a star to become a black hole, it has to be 8 times the mass of our sun or greater. And certain things have to happen at the end of its life. But our sun, our sun will not turn into will never turn into a black hole. But okay, if the sun magically turned into a black hole, there's actually an application I should show you guys called Universe Sandbox, and they've got a demonstration, and the sun is a black hole, the mass of the sun, and all of the planets are still in their orbits. None of them care. The only difference is the Earth got cold real fast because there's no more sun. So you can do thought experiments like that. So are we bright again? Why are we dim? Why is this so dim? My space engine just went crazy. Okay, I'm gonna close this down. I'm gonna show you guys something else, something that you guys can use rather than space engine, because this. Let's see. All right.
Somebody else asked if how do we know Jupiter is gas all the way through?
Spectroscopy, you could figure it out. And several probes that we've sent there. The Galileo mission had a probe that went down into the atmosphere of Jupiter. It's an interesting question, though. I wonder when they figured out that Jupiter was gas. Now, Jupiter's composition is like 75% hydrogen and 20-something helium. It's almost got the same composition as the sun, which is pretty interesting. All right, I'm going to share this out. NASA eyes, there we go. All right. So I've seen the NASA. Are you seeing NASA eyes here?
Yes, we are seeing.
All right. This is eyes.nasa.gov. This is NASA's website. They've been updating this quite a bit. Now at the very bottom here, Eyes on the Solar System. This is an installable app for the PC and Mac that lets you go anywhere in the solar system. And what they've done is they have a web version now, Solar System Interactive. This is really cool. It doesn't have as much stuff as Space Engine, but for a classroom and something, this is spectacular. So you can go to the inner solar system, outer solar system. Here's a bunch of missions. the DART mission, that's the double asteroid redirect test, the Lucy mission. You can go to any one of these, you can click on any one of these things. So that is pretty cool. The other thing that this thing has, eyes on asteroids. They just released this recently. If there's all the asteroids, quite a bit. Now, the one thing this has is the Asteroid Watch. This shows the 5 asteroids that are closest to Earth and their orbits. So if anybody tells you, if you see any news articles, something about asteroid passing really close to Earth, well, you can go here and see exactly how far it is now, because it drives me nuts when I see news articles that, asteroid to pass close to Earth, right? And there's a picture. Here's the Earth and this giant asteroid. Now, if you go here, let's see this. You gonna go there? You're not going to go there. Well, see, a lot of these guys, you can just barely see the Earth there, way off in the distance. So yeah, space is big. And even though there's 5 ones passing close, a lot of times they measure the distance of these passes in lunar distances. So there's one lunar distance. That thing is probably what, 8, 10 lunar distances away. Are you worried about that passing by?
We had a related question to that, Bob. How,
Yes.
how NASA determines what is considered to be a potentially hazardous size?
Yes.
And like, why did they pick the size they did for hazardous?
Potentially hazardous asteroid. I don't know if you're still seeing that. There it is a near-Earth object. Near-Earth objects are asteroids, comets, spent rocket casings and stuff like that. They're in an orbit that approaches the Earth. Okay, that is a near-Earth object. A potentially hazardous one is one that passes 0.05 astronomical units or 19.5 lunar distances, like I said. So if it passes within 19, almost 20 lunar distances, it's considered to be a potentially hazardous asteroid.
Does the size of the asteroid itself matter too, though? Jeff said 460 cubic feet was the cutoff, and he was wondering why.
That's a really good question. Some of these, asteroids come in all shapes and sizes and all velocities too. I guess the typical velocity asteroids pass by the Earth is somewhere between 20 and 40 kilometers per second. I've actually seen at the Minor Planet Center, I've actually seen some asteroids with a relative velocity of the Earth of like 1 kilometer a second. I'm wondering, okay, if that hit the Earth, would it even make a trail in the sky going that slow? But do we have a size here? Absolute magnitude. Yeah, some of these guys, 160 are estimated to be a larger than 1 kilometer, and we are not done finding them yet. Actually, what's really interesting is, let's see, JPL NEO stats, discovery statistics. This is really, really scary. There it is, asteroid discovery, near-Earth asteroid. The red line here are the big ones, larger than 1 kilometer. That's pretty much flattened out. 140 meters or plus, those are city killers, and we're still discovering those. All the rest of them less than 140. Look at that. That's almost an exponential curve. We are discovering them like crazy. And that started happening around 2000. Anybody know what happened around 2000 and why the asteroid discovery rate went up? Any guesses? It's CCD cameras were introduced and software to do follow-up observations started to be used. And that is why this curve started going crazy around 2000. So let's go back to eyes, get rid of the asteroids, it's NASA eyes. So they got the solar system interactive. You can go anywhere you want. You can see asteroids. Eyes on Earth. This is great for students doing Earth science and stuff, because here are all of NASA's Earth science probes, and you can see what they're looking at, vital signs, the visible Earth. I mean, this is Earth right now. That is what the Earth looks like. And it's got, does it have, sometimes they have like storms and stuff like that, but you can see carbon monoxide levels, carbon dioxide levels. So yeah, if you're a student doing some Earth science stuff, this site is just amazing, and they've got just tons of things you can do, animations of atmospheric rivers, see what every one of these probes is looking at. So that's really cool. Eyes on exoplanets. Remember I told you that we've discovered 5,000 some odd exoplanets? Well, you can go to every single one of them here. Now note, most of them are off in that direction, but you can click on any one of these guys and it will give you a representation of what that planetary system looks like, its habitable zone, and what the exoplanets look like there. And again, this all works on a web. This will even work on your phone. All of these apps will work on your phone. So it also has this. You can see the Mars 2020 rover descent and stuff. This Eyes on the Solar System. This is the older version of the app. They're not updating it as much, but I use it because I like it better. It shows the orbits a little better. So I use this in my weekly posts about astronomy. So you can download it for the PC and Mac. It is an installable app. It's not a web-based app, but it's got these solar system tours. It shows you how the Voyager mission worked, the Cassini mission to Saturn, and New Horizons Pluto flyby. And the New Horizons Pluto flyby, this was really, really cool. I don't want to launch that. What it did was I actually had this up and running when the New Horizons was flying by Pluto, and it was showing real time of what it was looking at and which instruments were active and stuff. So that's really cool. You can keep that running. I've had all of these running on computers at my wife's school when we had an astronomy night there. Just had these guys, and so that is all that. So let me see if Space Engine is going to not freak out anymore.
Someone suggested maybe it had to do with when you adjusted it for the black holes, but I don't know if it was something
You know what? You're right. Oh my goodness.
That's all right. We're getting to see all sorts of cool, good stuff. So
Oh, this is so. Yeah, I love this application. I've been covering the Messier objects in my weekly posts, and what really surprises me is, so let's go to. He's right.
Well, I hate to
Is-
say this,
Yes.
but we're going to have to start folding our tent.
Oh my goodness, it's 7:21. I didn't
Yeah.
realize it was that late. Well, the
So-
last thing you can do is go out to the edge of the universe
Mhm.
oh,
and see.
you're not sharing your screen
Those
yet.
are. Oh, I'm not. Oh, shoot.
There we go.
So here's our Milky Way. And once you get out past the Milky Way, all of those things, those aren't stars, those are galaxies. All of those are galaxies, and you start to see some of the structure of the universe. I wish they do this part a little better to show the cosmic web a little better than this. But considering that one guy was developing this application for years and years, I'll give it to him. It's pretty amazing. So does anybody have any other questions? Any place you want to go?
I have lots of questions people asked.
Okay, what do you got?
So, and some of them are just fact things, so you may know, so we'll see. Do you know anything about a rover plan for Venus? They said the steampunk analog Venus rover. So I'm assuming that's a specific one that maybe somebody's been.
I don't know if we have any materials that can withstand Venus for more than a couple hours. I mean, we're talking what, 700 or 900 degrees?
Yeah.
It would be great. I would love to see more Venus landers. But a rover, that would be awesome.
Yeah.
But I said I know that we're going to be sending 2 probes back to Venus and studying it and doing radar and studying its atmosphere, and that's happening in the very near future.
Can moon landing sites or rovers landing sites on other planets be observed from here on Earth?
No,
Okay.
too far away, too small. We can't even see. It takes an orbiting spacecraft around the moon to image landing sites. And as a matter of fact, if you take a look, was it the Chinese or was it the Indian? I think it was the Indian. Somebody just recently imaged the Apollo landing, all of them, at high resolution, and you can see everything. You can essentially see the walking trails where the astronauts walked. It's amazing, but that requires you to be really, really close. We don't have anything that can see that far.
Got it. Jennifer, am I allowed to keep going through questions? How's our
We can
time?
keep going on for a bit. I'd like to ask whether people would like to see Bob back again, so he can finish his talk. I really appreciate everything, Bob. This has been a great.
Yes, this is a fun one.
I love doing this. I mean,
we have more time.
The universe is so amazing, and I've loved this since I was a kid, and being able to share this love with people is just awesome.
Mm-hmm. So we can answer a few more questions. Ask a few more questions, Megan.
Okay, I've got a few more here. Will water that's on the moon and elsewhere be useful to us as humans, or is that water irradiated and dangerous?
No, I don't think it's irradiated, but they're going to have to extract it. They're looking for ice. I know that they're looking for ice and some of the deeply shadowed craters on the moon's poles, and they're going to be able to process. There's a lot of water bound up in the rocks and regolith and stuff. They'd have to use a processor to get that out. But yeah, no, if having water on the moon that we can get to without having to lift it out of Earth's gravity well and land it on the moon, yeah, that's very advantageous.
We had several different questions that I think fit together about the sun. People were asking about, so maybe you can just give a general overview related to sunspots and flares, and then how they correspond to the aurora. And when people were talking about the sun flares the other day and how it affected a solar storm, like what is a solar storm?
Wow, I have a whole presentation about this.
Maybe that's what we bring you back for. You do the 2-minute version?
Let's see, share. This is the Solar Dynamics Observatory site. This is what I mentioned about showing the sun in real time, essentially. This is the last 48 hours of the sun. So you can see a lot of prominences. Now in the center there, we are just flaring like crazy here. These things are called prominences. They are essentially clouds in the sun's atmosphere. They're plasma, and this is all plasma, all right, which is ionized hydrogen gas, and well, every other element in the periodic table is in here, but mostly hydrogen gas. So these guys are sticking up probably, well, we're 865,000 miles across. So this is tens of thousands of miles up from the photosphere here. But you can see all the flares and stuff. Now, when these flares happen, big ones, they can pull material off the sun and spit that out into the solar system, and that it's charged particles and stuff like that. If those hit the Earth's magnetic field, they can bring charged particles down into the atmosphere, and they can cause aurora. And when the aurora, what that is it's energized particles hitting nitrogen, oxygen, and stuff like that in our atmosphere, and essentially causing them to like fluoresce, and it causes them to light up and release energy. Really big flares, they can cause something called a geomagnetic storm, which they can take out satellites. It can cause weird stuff with radio. I mean, I remember the last solar maximum, a buddy of mine called me and said, I've got a ham radio here, and I'm picking up 7 channels in at once, and there's weird stuff going on like that. So this. Oh, wow, that is really active down there. So this site allows you to see several different versions of the sun. That was it allows you to see the prominences and stuff, kind of like a hydrogen alpha telescope. This is ultraviolet. This is the corona. You can see the corona is really active. These are coronal loops, plasma flowing along these coronal loops. There's sunspots here. You can see a loop going between the sunspots. Wow, is that active? Wow, there's a lot of stuff going on. We are not near solar maximum yet.
Yeah, that's amazing. We had another solar question. Apparently NASA released a video about the sound of the sun.
Yeah, I saw that they mapped the sound of the sun. Yeah, that's.
So the question is, how do you do that if you can't hear things in space because it's a vacuum?
Well, the same thing that's going on with the SDO there. All of that yellow stuff that you were just looking at, that's ultraviolet. You can't see that at all. So what they do is they map the ultraviolet down to something in the visible spectrum that you can see. And the same thing with the sound. What they did was they took the thrumming of the sun and put it to sound. They map it into something that you can interpret. I'm not exactly sure what process they use to do that. They've done that. I think the Voyager did that with cosmic rays from interstellar space as well. It's the sun doesn't really have a sound. In space, no one can hear you scream.
Okay. So Jeff asked, this is a little bit more of a technical question. With the solar prominences, since they come from the hot corona, he's wondering how they maintain a cooler temperature that's more similar to the sun's surface.
Wow. That's pretty technical.
Jeff's good at technical questions. I like
wow.
Jeff is very good at technical questions.
I can't answer that, Jeff. I'm sorry.
It's good to stump.
Well, you stumped me. Well, there's some really weird stuff going on with the sun's corona. I mean, supposedly it can be millions of degrees, but it's so tenuous that I think they just figured out what does space taste like. Okay.
That's Tim Ryan.
What does space taste like? Well, my sandwich that I just ate is in space, essentially, and that's what it tastes like. I have a lot of people ask me, do I believe there's life in outer space? And my question to that is always, where do you think you are?
We have a related question to that too, Bob. Maybe.
What do you got?
Besides the Earth, where's the best place in the solar system to look for multicellular life?
Multi-cellular?
I know, that was the tricky one.
It'll be great if we find multicellular life. Well, that's probably it. I mean, if you're talking about finding life in the solar system, you're not talking about this. You're talking probably microbes or something like that. I don't know if we're going to find multicellular. If we find unicellular, that would be great. But it would be life likes energy, and life likes water, at least as far as we know. So this is why they're looking at Europa and Enceladus, because hydrothermal vents, heat, energy, and water and a lot of different chemical compounds around there. So that's why they're looking at Enceladus and Europa.
Awesome.
I hope they find something. It would really change the world.
Yeah. Jennifer, I had a bunch more questions, but I feel like we might have hit the time limit. So I think we hit the main theme ones. So I'll apologize to folks if we didn't get to your specifics.
Yes, I am sorry if we didn't get to your questions. We had so much fun with Bob that
I
we
love
didn't
showing
get
this
a chance
stuff.
to. Yes, I know you were having fun. So we will definitely invite Bob back. I don't know for sure when. I put in the YouTube link again but you can find it from the library's website. It will probably be next week before this is loaded there. We've also got
Thank you, everyone.
next month. It's on the life cycle of a star. Well, multiple stars. I
remember giving
that.
a presentation about that in my high school English class. I had to write a paper, so I did about the life cycle of stars. Gosh, I'm a geek.
So that is next month. Now, next month will be on a Wednesday, not Tuesday. We're almost always on the fourth Tuesday, but we have to vary that sometimes. So thank you, everyone, for coming.
Good night, everyone. Thank you for coming.
Let us know. I will send out information to people. If you follow me on Eventbrite, I'm not trying to get followers. I'm not trying to build my numbers, but that way you'll see my events when they're posted. Yes, good morning in India. So thank you, everyone. I'm glad you came.
Thanks for coming.
And thank
Appreciate
you,
it.
Bob.
Yes, this was
Thank
a
you,
great
Megan. I always appreciate your help.
You too, Jennifer. Thanks for coordinating us. Bye, everybody.
Okay. Goodbye.
Night, morning, wherever you are.
Whatever.
Yeah.
Somewhere in time. All right. Good night.
Good night.
Or good morning.